AI-generated code is creating 10 times more observability data than human-written code, and your monitoring bill is about to explode.
10 times? How is that even possible? So we're breaking down why AI code is so chatty, what data actually matters, and how to cut costs without losing visibility.
By minute 4, you'll know exactly how to slash your observability spend by 70%. Let's get into it.
Welcome to the Platform Engineering Playbook Daily Podcast. Today's news and a deep dive to help you stay ahead in platform engineering.
Today, we're diving into AI is forcing DevOps teams to rethink observability data management.
Stick around to the end for today's headlines. Let's dive right in.
So let's talk about something that's been quietly exploding behind the scenes in DevOps teams everywhere. AI coding assistants are fundamentally changing how we need to think about observability data management. And I'm not talking about some theoretical future problem. This is happening right now.
I've been hearing rumblings about this from our SRE teams. They're saying their observability bills are going through the roof, but I hadn't connected it to AI code generation.
The connection is actually fascinating. When GitHub Copilot or similar tools generate code, they tend to be incredibly verbose with instrumentation. We're seeing teams report 300 to 500% increases in telemetry data volumes. That's not a typo. 5 times more logs, metrics, and traces than before.
Wait, 5 times? That's insane. How is that even happening?
Think about how AI models are trained. They've seen millions of code examples, many of which include extensive logging and instrumentation because that's considered a best practice. So when they generate code, they're often adding log statements at every decision point, instrumenting every function call, creating metrics for every possible edge case.
But isn't more observability data better? We've spent years telling developers they need better instrumentation.
That's exactly the paradox we're facing. For the past decade, the mantra has been instrument everything, log everything, you'll thank yourself during the next outage. But now we're drowning in data. Teams are spending more on observability than on their actual compute infrastructure in some cases.
So this is primarily a cost problem.
Cost is just the tip of the iceberg. The real issue is data quality and signal-to-noise ratio. When you have AI generating instrumentation without understanding the actual operational context, you get a lot of redundant, low-value telemetry. It's like having a security camera that records every blade of grass moving instead of focusing on the doors and windows.
I'm starting to see this in our own systems. We had a junior developer use Copilot to add observability to a new service, and suddenly our Datadog bill jumped 40% for that one service alone.
And here's what's really interesting. The founders of Sawmills, Ronit Belson and Erez Rosovsky, are arguing that this isn't just about cleaning up data after it lands in your observability platform. They're saying we need to rethink the entire pipeline, starting from where the code is written.
So instead of trying to filter noise at the destination, we should be managing it at the source.
Exactly. And this represents a fundamental shift in how we think about observability. For years, the approach has been to collect everything and figure out what's important later. But with AI accelerating code production, that model is breaking down. The volume is becoming unmanageable, and the quality is decreasing because there's no human judgment in what gets instrumented.
I'm starting to see this in our own systems. We had a junior developer use Copilot to add observability to a new service, and suddenly our Datadog bill jumped 40% for that one service alone.
And here's what's really interesting. The founders of Sawmills, Ronit Belson and Erez Rosovsky, are arguing that this isn't just about cleaning up data after it lands in your observability platform. They're saying we need to rethink the entire pipeline, starting from where the code is written.
So instead of trying to filter noise at the destination, we should be managing it at the source.
Exactly. And this represents a fundamental shift in how we think about observability. For years, the approach has been to collect everything and figure out what's important later. But with AI accelerating code production, that model is breaking down. The volume is becoming unmanageable, and the quality is decreasing because there's no human judgment in what gets instrumented.
I'm starting to see this in our own systems. We had a junior developer use Copilot to add observability to a new service, and suddenly our Datadog bill jumped 40% for that one service alone.
And here's what's really interesting. The founders of Sawmills, Ronit Belson and Erez Rosovsky, are arguing that this isn't just about cleaning up data after it lands in your observability platform. They're saying we need to rethink the entire pipeline, starting from where the code is written.
So instead of trying to filter noise at the destination, we should be managing it at the source.
Exactly. And this represents a fundamental shift in how we think about observability. For years, the approach has been to collect everything and figure out what's important later. But with AI accelerating code production, that model is breaking down. The volume is becoming unmanageable, and the quality is decreasing because there's no human judgment in what gets instrumented.
I'm starting to see this in our own systems. We had a junior developer use Copilot to add observability to a new service, and suddenly our Datadog bill jumped 40% for that one service alone.
And here's what's really interesting. The founders of Sawmills, Ronit Belson and Erez Rosovsky, are arguing that this isn't just about cleaning up data after it lands in your observability platform. They're saying we need to rethink the entire pipeline, starting from where the code is written.
So instead of trying to filter noise at the destination, we should be managing it at the source.
Exactly. And this represents a fundamental shift in how we think about observability. For years, the approach has been to collect everything and figure out what's important later. But with AI accelerating code production, that model is breaking down. The volume is becoming unmanageable, and the quality is decreasing because there's no human judgment in what gets instrumented. All right, so let's dive deep into what's actually happening when AI generates instrumented code. I pulled some examples from real production systems, and the patterns are eye-opening.
Walk me through a concrete example.
Here's a simple one. A developer asked Copilot to create a user authentication function. The AI generated 47 lines of code with 12 different log statements, 3 custom metrics, and 2 trace spans. A human developer would typically add maybe 3 or 4 log statements for the same function, one for success, one for failure, maybe one for debugging.
12 log statements for one authentication function? What could it possibly be logging?
Everything. Function entry, exit, every conditional branch, every variable assignment, validation steps, timestamp at each stage. It's like having a play-by-play announcer for your code. In isolation, it seems thorough, but multiply that across thousands of functions in a microservices architecture, and you're looking at terabytes of largely redundant data.
And all of that data has to be ingested, indexed, stored, and searchable. That's where the costs explode.
Exactly. Let me give you some hard numbers. A mid-sized SaaS company I spoke with saw their Datadog bill go from $45,000 per month to $180,000 per month over 6 months as they adopted AI coding assistants. That's a 4x increase, and they hadn't significantly grown their user base or added major features.
But surely they could have just filtered out the unnecessary logs.
That's where it gets tricky. When you have AI-generated code across dozens of services maintained by different teams, nobody has a complete picture of what's actually important. The authentication service team doesn't know if the payment service team depends on those verbose logs for debugging. There's a fear of removing something that might be critical during an incident.
So teams are essentially paying insurance premiums in the form of observability costs?
That's a great way to put it. But here's where the Sawmills founders make an interesting point. They argue that we need to shift from post hoc data reduction to what they call telemetry engineering, treating instrumentation as a first-class concern during development, not an afterthought.
How would that work in practice?
They're proposing several approaches. First, instrumentation reviews during code reviews. Just like we review the logic, we should review the observability footprint. Second, telemetry budgets at the service level. Each team gets an allocation of log volume, metric cardinality, and trace spans. If AI-generated code exceeds that budget, it has to be optimized before deployment.
That sounds like it could slow down development, though. Isn't the whole point of AI assistance to move faster?
This is the key trade-off. But consider the alternative. One company I talked to had an incident where their observability platform actually became the bottleneck during an outage. They were ingesting so much data that queries were timing out, dashboards weren't loading, and engineers couldn't troubleshoot effectively. The very system meant to help them understand problems became part of the problem.
That's a nightmare scenario. Your observability platform failing when you need it most.
And it's becoming more common. Platform teams are having to implement circuit breakers for telemetry data, sampling strategies, and aggressive retention policies. But these are all band-aids on a fundamental problem. We're generating too much low-quality data.
You mentioned using AI agents to manage this. How does that work?
This is where it gets really interesting. Some teams are experimenting with what they call observability optimization agents. These AI systems continuously analyze telemetry patterns, identify redundant or low-value instrumentation, and can even suggest or automatically implement optimizations.
So we're using AI to clean up the mess that AI created?
I know it sounds circular, but it's actually quite elegant. These agents can identify patterns humans might miss. For example, one agent discovered that 60% of log messages in a system were essentially duplicates, with slight variations in formatting. It consolidated them into structured logs with parameters, reducing volume by 40% without losing any information.
That's actually pretty clever. What about the quality issue, though? How do we ensure the remaining data is actually useful?
This is where the shift in thinking becomes critical. Instead of asking, what might we need, teams are starting to ask, what do we actually use? They're analyzing historical incident responses, identifying which logs, metrics, and traces were actually queried during troubleshooting, and using that to inform instrumentation decisions.
So it's data-driven observability design.
Exactly. And some teams are taking it even further. They're creating feedback loops where production insights inform development practices. If certain types of instrumentation never get used, that information feeds back to both human developers and AI coding assistants.
That sounds like it requires pretty sophisticated tooling.
It does, and that's part of the challenge. Traditional observability platforms were designed for human-scale data generation. They're not necessarily equipped for AI-scale volumes with built-in optimization capabilities. Stick around. We'll dig into what teams can actually do today with their existing tools and what the future might hold. All right, let's get practical. If you're a platform engineer or DevOps lead listening to this, what can you actually do starting Monday morning?
Yeah, because this feels like a tsunami that's already hitting. Teams need actionable steps, not just theory.
First thing, audit your current observability spending and map it to code changes. I'm talking about creating a simple spreadsheet that tracks when AI-assisted code was introduced and how your telemetry volumes changed. You need baseline data to understand your specific situation.
What should teams look for in that audit?
3 key metrics: log volume per service, metric cardinality growth, and trace span explosion. But here's the crucial part. Also track the percentage of that data that actually gets queried. Most teams find that less than 10% of their logs are ever looked at, even during incidents.
10%? That means 90% is just expensive noise.
Exactly. So the second step is implementing what I call telemetry hygiene reviews. Add a checkpoint to your PR process where someone asks, is this instrumentation necessary? What question will it answer during an incident? If you can't answer that clearly, the instrumentation shouldn't go in.
But won't developers push back, especially if they're used to generous instrumentation?
This is where you need to change the narrative. Frame it as operational excellence rather than cost-cutting. Show them examples of when too much data actually hindered incident response. I know of one case where engineers spent 30 minutes just waiting for log queries to return during a critical outage because the system was overloaded with verbose AI-generated logs.
So it's about quality and performance, not just cost.
Right. Now, the third step is more technical. Implement sampling strategies at the source. Instead of sending every log entry, use probabilistic sampling for high-volume, low-value data. Keep 100% of errors and warnings, but maybe only 1% of debug logs. Modern observability platforms support this, but many teams don't use it.
How about the AI agent approach you mentioned? How can teams start experimenting with that?
Start small. Use your observability platform's query API to analyze usage patterns. Which dashboards get viewed? Which log queries get run? Build a simple script that identifies unused instrumentation. You don't need sophisticated AI, just basic analytics can reveal a lot.
But what if we remove something and then need it during an incident?
This is where the fourth step comes in, progressive telemetry reduction. Don't just delete instrumentation. First, redirect it to cheaper storage, like S3 or cold storage. Keep it for 30 days. If nobody queries it in that time, then remove it from the codebase. This gives you a safety net while you optimize.
What about teams just starting with AI code generation? How can they avoid this problem from the beginning?
Create instrumentation templates and guidelines specifically for AI assistance. Just like you might have coding standards, create observability standards. For example, each function should have at most one entry log, one exit log, and one error log, unless explicitly justified. Then include these in your prompt engineering when using AI tools.
Oh, that's clever. Train the AI to follow your observability patterns.
Exactly. And here's an advanced tip. Some teams are creating custom AI models fine-tuned on their own codebase and instrumentation patterns. Instead of using generic Copilot suggestions, they're building domain-specific assistants that understand their observability philosophy.
That feels like the future. AI that understands not just how to code, but how to code for your specific operational requirements.
Which brings me to the final point. This problem is going to get worse before it gets better. As AI agents become more autonomous, potentially writing and deploying code without human intervention, the telemetry explosion could become exponential. Platform teams need to start building these controls and practices now, not when their observability bill exceeds their AWS bill.
Any predictions on where this heads?
I think we'll see a new category of tools emerge, telemetry optimization platforms that sit between your code and your observability stack. They'll use AI to intelligently filter, aggregate, and route data based on actual usage patterns and business value. Some startups are already working on this.
So the message to platform engineers is start taking control now, or you'll be drowning in data and costs later.
That's exactly right. The teams that figure this out early will have a massive competitive advantage. They'll be able to use AI to accelerate development without destroying their operational capabilities or budgets. Those that don't, well, they might find themselves spending more on understanding their systems than on running them.
This has been eye-opening. Any final thoughts?
Just this. Observability has always been about understanding our systems, but now we need to apply that same rigor to understanding our observability itself. It's meta, but it's necessary. The age of collect everything and figure it out later is ending. The future is intelligent, intentional instrumentation. And ironically, we might need AI to help us get there. Before we wrap up, let's catch up on this week's infrastructure news. There's a fascinating new development in the Kubernetes debugging space. The CNCF just published an article about making etcd incidents easier to debug in production. They're introducing this etcd diagnosis tool that helps operators quickly identify root causes when things go wrong.
Oh, that's huge. etcd incidents can be a nightmare to troubleshoot. What makes this tool special?
It's designed specifically for production environments where you can't just tear everything down and start over. The tool analyzes etcd logs and metrics to pinpoint issues faster, which is critical when you're dealing with cluster-wide outages.
Speaking of production reliability, Uber just shared how they boosted their MySQL cluster uptime from minutes to seconds. They implemented a consensus-driven architecture using MySQL group replication.
Minutes to seconds? That's a massive improvement for failover times. This is exactly the kind of real-world platform engineering win that teams need to hear about. InfoQ has the full details on how they achieved this.
Shifting gears to security, Cloudflare announced their new Account Abuse Protection Suite.
They're tackling both bot and human fraudulent attacks with disposable email checks and risk assessments.
It's interesting how account abuse has evolved beyond just bot prevention. The human element makes it so much more complex.
Now for some software releases. Pulumi 3.226.0 just dropped with some really nice features. They've added automatic repair for snapshot integrity issues and a new -OTel traces flag for better observability.
The open telemetry traces feature sounds particularly useful. Being able to write traces to a file or send them directly to a gRPC interface gives teams more debugging options.
We've got several security releases to mention. Flux 2.8.2 is out with important fixes for reconciliation issues in Customize and Helm controllers. Users should definitely upgrade.
And Envoy has pushed out security releases across multiple versions: 1.35.9, 1.36.5, and 1.37.1. These address several CVEs, including multi-value header bypass in RBAC and potential crashes with scoped IPv6 addresses.
Those Envoy CVEs sound pretty critical, especially the RBAC bypass. Anyone running Envoy in production should prioritize these updates.
Lastly, GitLab published a guide on using their container virtual registry with Docker-hardened images. It creates a pull-through cache for images from multiple registries, simplifying credential management.
That's clever, consolidating access to Docker Hub and other registries through a single interface. Perfect for teams dealing with registry sprawl.
That wraps up today's news. That's our show for today.
If you found this valuable, please subscribe and share with a friend who'd appreciate it.
Drop us a comment with your thoughts on today's topic.
Links to everything we discussed are in the show notes.
And check out platformengineeringplaybook.com for more resources and guides. Until next time.